Today we are going to discuss about Postgres database architecture. Before we are going to see Postgres architecture, let me see the introduction. In 1985, University of California at Berkeley, they introduced Ingress database. So once the project has been officially ended in 1986, Postgres was introduced as Postgres SQL. So later on the evolution, the first version of Postgres 6.0 was released on 1997. Then what kind of architecture it have? The Postgres is basically RDBMS. The core was developed on RDBMS and it will support NoSQL also. That's why Postgres will support RDBMS and NoSQL. And it architecture is MVCC, multi-version concurrency control. So read process will read it and write will write at the simultaneously. It won't make any locks on the transaction. That is the beauty of the Postgres, and it will provide the features is reliable and scalability, table space shredding, and high availability, and the world advanced open source. That is the major key source of the Postgres. So we see the database architecture. So whenever the client is request, the server will respond. Postmaster is the first background process when the database is up and running. All the new connections will land on the postmaster. Postmaster will check the user authentication. Once the user authentication is passed, it will span a new connection or else it will create a new process. This process is called PG process. Once the connection is established, the client will directly talk to PG process. PG process will take care of the user request. Database server consists of instance and database. The default instance name is Postgres. Default database name is Postgres. Whenever the user or client give the request, it will fetch the information from database and it will respond to it. So instance is a combination of memory structure and background process. Memory structure consists of three types: shared memory, work memory, and maintenance memory. Shared memory consists of shared buffer and wall buffer. So the background process is a establish the connection, enforce the relationship between instance and a database. Postmaster, background writer, wall writer, checkpointer, archive writer, log writer, stats collector. So these are the major background process. In the database, it consists of physical structure and a logical structure. In the physical structure, it consists of data file, wall file, archive log files, and configuration files. In logical structure, it will consist of table space, tables, index, and others. So in the memory structure, we already seen about three things: shared memory, work memory, maintenance work memory. In shared memory, we have already saw it consists of shared underscore buffer, wall underscore buffer. Shared underscore buffer will consist of whatever the user is requesting. It will fetch the data and it will copy the blocks and it will respond to the user. In case the same data is requesting from the user, it will give from those blocks. It is nothing like that database buffer cache in Oracle. Wall buffer wall buffer is maintained for recovery. Whatever the changes happen in the database, those changes are copied into the wall buffers. Next one is work memory. Work memory will do the memory allocations for order by, group by, these kind of things. Whenever the user is connection, it will allocate the memory. Whenever the user is disconnected, it will deallocate the memory. It is nothing like that. PGA in Oracle. Maintenance work memory. Maintenance work memory will take care of all the maintenance activity like index creation, alter index, and vacuum process, vacuum full. Those kind of maintenance activity will take care of maintenance work memory. For the shared buffer, default parameter is shared underscore buffer. The shared buffer size is maximum 25% of the RAM size. Wall buffer default size is 64 KB, and maintenance work memory will allocate the size depends upon the environment. Why we need a separate memory structure for all the database, for all the activity? Because in Postgres, all the memory, all the activity requires some kind of memory. So those architecture will allocate the memory based on the activities. Checkpoint process. Whenever the database buffers having a changes, those changes are captured on the wall buffer. From the wall buffer to wall log files, it has been written through wall writer. So what is the checkpoint? The checkpoint is a process. It holds the changes of the database. Whenever the checkpoint happens, the database backup has been started, the backup has been hence new DB creation and the dirty blocks available on the buffers. These changes would not be available on the disk. It will be maintained on the wall log files. So it is used for recovery. Recorded or modified blocks, whatever the maintains in that wall buffer at the checkpoint event will return into the wall files. Third one is RQ process. RQ process is mainly used for hot standby replication. By default, the database is in no RQ log mode. This RQ logs is a copied of wall files. Otherwise, the wall files will return into itself. So those information of the database will be not secured. So how the RQ log has been enabled? The parameter is there RQ underscore mode equal to on, and that RQ underscore command we need to give the specific location where would be the wall files are maintained. Before the 9.5, the wall files are maintained in PG $PG data PG underscore xlog location. Wall files are stored it. If we never enabled RQlog mode, that those wall files are written again and again, it will return on the same file. But in real time, we should enable the RQlog mode. Then only those informations will be maintained into RQlogs. Through that RQlogs, we can able to build the hot standby or replication. Next we are going to see logger process and a statistics collector. Logger process, which is used to collect all the error logs and OS level logs, it will collect on this file. Statistics collector, which is used to collect the DB level statistics. It is mainly used for performance tuning. Data files, this is the file which contains the user information and the transactional information. In Oracle, we will say that data file, the same file, same thing like that, we will call it a data file here also. And next one is wall file. Wall file is nothing like that. Whatever the transaction or happen in the database, it will store the information. It is main purpose for recovery. And archived wall files. Archived wall files are maintained, which is the copy of the wall files. It will store the transactional information and it is main purpose for replication. And one important thing, wall files are located on till 9.5. We have a pg underscore xlog. So over there that wall files has been maintained. In archive log, files should be maintained on the archive location. If we mingled together, it is highly risk. So we need to maintain the wall files separately and archive logs separately. So it is like redo log and archive log files in Oracle. So in Oracle, we will purge the archive log files manually. The same thing we have to perform on here also. Next one is configuration files. The configuration files will contain the information of all the parameters. So this is the main file which hold the information of all the things. If we need to change any parameter, we should bring down the service and we should change the parameter. Then we need to start the services. These are the files which is available on physical structure. In a logical structure, we have table space and tables. Table space, each database having a ID which consists of table space and separately. So those table space having VM and FSM files. VM in the sense virtual memory and free space memories. So each table spaces having each database having separate table space. So this is the main advantage of the Postgres. Next one is one table can be accessed by different database and different database can be accessed on different user. So this is the logical structure of the database. So here we completed the overview of Postgres database architecture.